For this project, I'm using meter RSVP event data um, that is published on the Satori. This stream collects the live RSVP event data around the world in real time. And at high level, this is my pipeline architecture. So you can see I'm using Apache NiFi to collect the data from Satori, the meetup event data. Then I'm loading into Apache Kafka. Then I'm using Kafka Connect to load data from Kafka to Elasticsearch Index. Then I use Kibana visualization tool to create the dashboard. This will be my real-time streaming pipeline. For the long-term storage and analytics, Adobe Query Analytics, I'm using S3 and Amazon Athena. I'm using Kafka Connect for S3 to read data from Apache Kafka topic and writing into S3 bucket. Then I use Athena to query any Adobe date query on top of S3. Athena uses Presto as the underlying query engine. So let's go back to the details. And this is my NiFi console. And this is my real-time streaming data flow. I'm using the consumes Satori to collect data from Satori. Then I write the data collected here to the Kafka topic using the publish Kafka processor. This is a one-time data loading. Right now the real-time stream doesn't have the category information. It only has a group ID. So I downloaded the static data for the categories with the mapping with the categories and the group ID from Meetup um, using the REST API, and the data is in CSV format. It has three fields. So this is the category ID, this is a category name, and this is a group ID. So in the real time, I have only the group ID, so I'm going to join on this field to get the category name in the final output. So my NiFi, so I'm to capture the event data, the one-time CSV file, which has around 300,000 groups. I'm using this pipeline reads the file, adds the schema attribute with the schema structure, and then converts the file from CSV to JSON, then writes into a Kafka topic. This will be a one-time load, and this is my streaming pipeline. So the data, I'm using the Confluent version of the Kafka, the Confluent Community Edition. It has more features than the open source. So these are the different components in the Confluent version, and list of Kafka connectors. These are the various connectors available. I'm using the Elasticsearch sync for the loading data into Elasticsearch, and S3 sync to loading data into S3 from Kafka. Let me log into Kafka SQL. Kafka SQL is a SQL engine on the streaming data. You can query the stream in real time. So I've created some streams. So this is my raw RSVP stream on top of my RSVP, the raw events from NiFi. This is the expanded version of the JSON. I flattened the JSON file into this stream and also converted time fields from epoch to date format. This is my enriched stream with the category name that we read in a different topic. And then I've created some tables. This is my reference table with the category information. I'm going to join this reference table with this stream on the group ID, and this is the final table with the information. I'll show the queries. So my Kafka, this is my raw stream on the raw topic. Then the flattened JSON structure from the raw stream, extracting various fields, also converting the epoch to MMDD YY date format. And this is my Kafka table with a group ID as the key, and this is my Kafka topic. The difference between a Kafka stream and a Kafka table is the stream is immutable, whereas the table is mutable. And Kafka right now allows only joining a stream with a table, so I have to create this as a table. And I'm creating a enrich table to get my category name along with the rest of the fields joining on the group ID. Kafka also allows you to create a tumbling window function on a stream, and so this is a tumbling window 5-minute. The query captures 5-minute tumbling window information for the top categories and top cities in the 5 minutes window. And let's see the output. So this is my final detail table with the category information, and this is the real-time streaming data as it coming. And I already queried the top cities and top category windowed function tables in JSON format. You can see this is the top categories, and this is the epoch window. It started at this time, and you can see it keeps increasing the updating the count as it sees new event. And this is the top cities in this 5 minutes window, and it keeps adding the count as it sees more events for a specific city. I'm using Kafka Connect for Elasticsearch to move data from Kafka to Elasticsearch. Here is my configuration, and my connector is running right now. The data is loaded into an index in Elasticsearch, and this is my index. This is my mapping, and let's query for last 1 hour data. This one is how many events are there in past 1 hour, around 6,700. So I'm going to go to the Kibana dashboard to show you the different dashboards we built. This is the real-time data, and let's go to the dashboard. So this is the top 5 RSP categories per hour. So you can see all the top categories, the top 5 countries, and top 3 active groups by city. So New York, these are the groups. In London, these are the top groups. For the Barcelona, these are the top 5 events within this time frame. So these are the events top 5. And so I will go back to my, so this is my real-time pipeline I just showed you. I'm going to show you this, my Arab query pipeline on the permanent storage data S3. Let me show my S3 connector. This is my character information. It has all the fields. My connector is running. The data is loading into S3 bucket. So this is my S3 bucket. Under that, the topic, this is my topic name. These are partitions, one for each Kafka topic. And my data is coming in JSON format. You can open one file and see how the data looks like. So these are my event information captured from Kafka to S3 using the connector. Then I'm going to use Amazon Athena to query the data. Athena uses Presto query engine under the covers. It's the most popular query engine. You can query multiple data sources. Here I'm creating, this is my database name. This is my table I've created on pointing to my S3 location, and I can query data from S3 directly. I don't need to create any database. So these are my top events by country. These are, for a particular time period, top categories. And also, just for experimental purpose, I'm using Apache Drill to query data directly from Kafka topic. This is my configuration in Apache Drill, connecting to Kafka directly and querying a specific topic. And let me show you running one query, and you can see the result. This query is running in Apache Drill, connecting to the Kafka source. So this is an alternative to Presto, but here you can also query directly from Kafka itself. I also written a Spark streaming application to calculate the 5-minute top categories in 5-minute window using the um, structured streaming in Spark. So this is my program. Let me run it. So here is my data as it gets new events. It keeps updating the count for that 5-minute window from 550 to 555, and it shows the count in real time. I'm going to start it here. Thank you for watching.